Guys, this is Mayur again. Today I'm gonna teach you how to mark bode plots in control systems. Many of the guys are complaining that bode plots are too difficult. We don't know how to mark it. So complex. I'm gonna tell you guys, it is not that complex. The complexity comes with our own mind. We create complexity. Now, just stay focused, and I'm gonna show you how to mark bode plots. Let's start. I'll give you an example of bode plot. It will make you learn quickly, easy. Let's take an example. This is my transfer function. Let's take an example like okay, fine. Yeah, that is cool. First, the main thing about bode plot that we have to solve, how to solve it. The basic thing we have to start with is like step one is like just convert this term in the form of 1 plus s. 1 plus s form. Just convert it like this. 40. I will take 5 common to convert it in a 1 plus s form like 1 plus s by 5. Take the similar way s, 10 common, 2 common, 1 plus s by 10 and 1 plus s by 2, which comes out to be 10. 1 plus 0.2s by s, 1 plus 0.1s, 1 plus 0.5s. Now put s equals to j omega. As you all know, s is equal to j omega. It's really 10. 1 plus 0.2 j omega by j omega, 1 plus 0.1 j omega, 1 plus 0.5 j omega. Now step 2. Okay, I'm going to turn the page now. Step 2. Step 2 is like, now we have to find the corner frequencies. This transfer function has two poles and two pole values like corner values and one zero value. So now corner 1 0 value. So corner frequencies comes out to be omega 1 equals to 1 by 0.5, which is a pole, equals to, which comes out to be 2 radians. And now second corner frequency equals to omega 2 equals to 1 by 0.2, which is 0 value, equals to, which comes out to be 5 radians. The third corner frequency equals to omega 3 equals to 1 by 0.1, which comes out to be 10 radians. Now, as we know that this type of transfer function, this type of transfer function has a value s in it only. So this is a first order function. Now for a first order function, due to the presence of the 1 by s in the transfer function, the initial slope of the curve will be minus 20 dB per decade. Now the initial curve is to be minus 20 per dB decade. This segment of magnitude plot is to be drawn with a stipulation that it will intersect with 0 dB axis at omega k equals to 10, like I'll tell with a function this like. We have to find the slope. Now the minimum frequency just we have to start the bode plot with. It's like 20 log 10 of k k. Here k equals to 10. 10, this one, this 10. Now you find the value like 20 log 10 of 10, it comes out to be 20 dB and 20 dB. This is our starting value. From this value we have to start marking our bode plots. And one more thing, that this is a first order system, so the initial slope would be minus 20 dB. But minus 20 dB. Now the initial slope is minus 20 dB, right? Initial slope minus 20 per dB. Now there's a pole. Always remember, for every pole there will be an increment of minus 20 in it, and for every 0 there will be an increment of plus 20 in it. Every pole minus 20, every 0 plus 20. Now here are now for first pole, slope equals to initial slope minus 20 plus minus 20. I told you, for every pole minus 20, it's like minus 40, right? Now one more pole. Now for 1 0, it is like minus 40, this flow plus 20. For every 0 plus 20, it comes out to be 20 dB. Now for second pole, you know, I told you at the starting there are 2 poles and 1 0. It's like 20 dB plus it's minus 20 dB plus minus 20 dB, which comes out to be minus 40 dB, right? These are our initial conditions. Now we have to find the angle, the degree. No, now we have to plot bode plot. Okay, I'll show you how to plot bode plots. Okay, I'm telling you a rough idea. Here is it. Now one more thing. I forgot to tell you that if our corner frequencies are like less than 10, then we have to start the plot by 0.1 value. Here we have to start this value at 0.1. Now, and if it is like equals to 10 or greater than 10, then you have to start by value 1, right? Now here you can see that the value is like 10, right? 10 equals to 10 or less than 10, equals 10 or greater than 10. Now we start the value by 1. So 1. Now corner frequency, mark the corner frequencies. Now 1, 2, 5 and 10. And in our initial slope, which we found out like this, 20 log K10, it comes over to 20 dB. I told you this is the value from which we have to start our bode plots. 20 dB, and 20 dB is like here. 20 dB. Okay, it's just a rough line. I'm going to tell you I'm just showing you how to mark bode plots. There are separate graph comes out to bode plots, you know how, and it'll be easy task for you to mark there. Now, for you have to now initial slope comes out to be now. For there is a corner frequency. For every corner frequency for a pole comes out to be 2 radian per second. For every pole there is a downward slope, and for every 0 there is an upward slope. Now for 2 there is a downward slope like this, right?